So this section is 11.1, and it's an introducing of the radical expressions. So if you take a look, a square root, recall that the square root is the number b is a square root of a if b squared does equal a. So here are two examples of 36, which is the a. So what two numbers could be squared that would give you 36? So 6 squared is 36, and so is negative 6 squared if you put brackets around it all. So this is set up for that. And then just finding square roots, they give you more examples. So if you're looking at 100, then the square root of 100 is going to be 10 or negative 10, because 10 squared will give you 100, and negative 10 squared will give you 100. So these are the basic setup for that piece there. So let's go to our pad for the radical expression. So radical expressions. So basically, if we have a square root of 6, the radical is this piece. That's called the radical sign. Okay, and the radicand is the expression under the radical sign. So the radicand is the 6. So if you were to evaluate the square roots, like for a, let's say the square root of 25, well, if we take 25 and break it up into factors, that would be 5 times 5. And radicals, or this radical that's here, this is actually a square root. So there's an assumed 2 here. And so since there are 2 of the same numbers inside the radical sign, it comes out as the answer of 5, or it could be negative 5. Because if I test it, 5 squared is 25, and negative 5 squared is also 25. So that works. If we did a different one, like the square root of 0.49, then again, this is the square root of 0.7 multiplied by 0.7. Okay, and since this is a square root, we have 2 of the same, so my answer is going to be 0.7, or it could be negative 0.7, because I can test that. 0.7 squared is going to be 0.49, and negative 0.7 will also be 0.49. Okay, and so these are the kind of setups we get. We do the same thing with fractions. If you have the square root of 4/9, then that's the square root of 2/3 times 2/3. And so again, we get 2/3, or it could be negative 2/3. And then the last one, we want to look at variables. So c squared, which is really assumed that we have to assume that c, of course, is going to be greater than 0, because we can't have a negative in there. So in these cases, all these were already positive, so they wouldn't be negative. So that means we have the square root of c times c, which is just c. So we get c this time. Okay, or we could have negative c. Okay, but they'll have to be positive in the end. Alright, so let's take a look at approximating a square root. So let's say you have the square root of 17. This one doesn't come out so nice. There is no nice square root of 17. But we do know that if we look at one that's slightly higher than that, like the square root of 25, and one that's lower than that, like the square root of 16, we know that these are typically 4 and 5. So which one is the square root of 17 closest to? Well, it's closer to 16 than it is to 25. So we can do a better estimate. And so now this would probably give us somewhere around 4 point, maybe 4.1, because it's just slightly bigger. And so if we did this on the calculator to see if we're close to that, we could get, so to get that we hit the second square root, and then we put in 17. And so yeah, it looks like it's about, if I know I could write all these numbers down, but if we had to round it, it would be what, 4.12. Okay, so this is rounding, and they will probably on the homework and quizzes tell you to round, you know, maybe to the thousandths, okay, or the hundredths, or the tenths. So you definitely need to do that. By the way, like this one here, this is the tenths, this is the hundredths, so if I did round it to the thousands, it would be a 3. Okay, because that's what it would be on the last number. So 1, 2, 3, and the number here is 1, so that's why it would be a 3. So that's basically the setup. If we're looking at a cube root, okay, then we are looking at the setup of b to the third equal to a, meaning that I have to have b times b times b equal to a. So an example might be 3 cubed would have to be 27, because 3 times 3 times 3 is 27. And so that's the cube root. And so if we look at other examples of cube root, we could look at the, and we write it with a 3 now. When we do the square roots, we don't have to write it because it's an automatic 2. But in this case, we put a 3, so negative 27. So if we break that up, okay, then what would give me negative 27 would be negative 3 multiplied negative 3 multiplied negative 3. And again, this tells me how many, okay, how many I have to have here. And since there's 3 of them here, my answer gives me a negative 3. And there is no positive 3 because I have to get a negative 27 in this case. So only negative 3 to the third gives me negative 27, because 3 to the third gives me positive 27, and that's not what I want. Okay, I wanted negative 27. So we can look at other examples, like let's say we're trying to well, before we get to that, let's just make sure that we see other examples. Let's see, let's do 1 to the fourth. So if I have a fourth root, and that's to the negative 81, could I come up with something? Well, in this case, for 4, if I tried 3 times 3 times 3 times 3, it gives me 81, but then it would be positive, positive 81 if I did that. If I tried them to be negative, that doesn't work either, because a positive, negative times a negative is positive, the positive times the negative is negative, and the negative times the negative is positive again. So again, I get the square root of 481, and so that doesn't work either. So this one is not a real root. So it's not a real root, not a real number, that is, that I can use. So it's not real. Okay, and later on we're going to discover that, not in this class, but in another course, you would know that it's called an imaginary number. And so we're not going to cover that in this course. So let's look at some other ones. So again, if we're going to have the expression of the square root of x squared, we have to infiltrate the fact that it's an absolute value. If we only want to look at the positive values. Okay? So whatever we get here has to be a positive value in the end. So for example, if I have the square root of -3 squared, then I get, well, -3 squared is 9, and then I also take the square root of 9, which is 3. And so in this case, if I have the absolute value here, and I did have a negative, it would come out as 3. And so that's what we always want to see, especially when we look at radicals with variables in them. Like, let's say we have the x plus 1 squared. We don't know what x is, we just know it's a number of some sort, so we have to basically infiltrate that it is going to be a positive setup. So in this case, I do have x plus 1 times x plus 1, and see, this 2 is telling me I have 2 of them. So when it comes out, we have to write it as the absolute value of x plus 1, because of the fact that we don't know if it's going to be negative or not, and if it's negative, it's not going to give us a correct value to that. And so that's why they do that. Another one, before we quit, is the square root of z squared minus 4z, and then that's plus 4. Here we have to break this up into two components. So that's going to be the z minus 2 times the z minus 2. And so then when it comes out, since I have two of them here, it's got to be the absolute value of z minus 2. And how I broke this up, you should have learned in another course, but I take the z squared minus 4z plus 4, and I usually use a window technique to understand how to break it apart. So this z squared will go here, and this 4 will go here, and then I figure out what multiplies to get this. So what times what is z squared? Well, that's got to be z times z. And what times what is 4? Well, that's a 2 and a 2. And so in the middle terms are here. They're split in half. So I have to think about that z times the 2 is 2z, and the 2 times the z is 2z. So if I add these, I get plus, so I'm going to have to make these negative. And if these are negative, that means these 2's have to be negative. And so -2 multiply -2 will give me positive 4. So it still works if I change the signs. But I need to get the middle term, and -2z plus the -2z gives me the -4z that I needed to get in the middle. So that's how I broke it up, because this piece here, the z minus 2, I put down, and then here's the other one, the z minus 2. So I have two of them. So you should have learned this in a previous course. So if you haven't, then you need to go back and review it. Either YouTube videos where someone's showing you how to do this, or you go back to it's somewhere in our book. It's there as well because we did it in Math 81.